You're listening to DTFHN for April 24th, 2026. I'm your structurally unsound host, Jack Haxman. We are your daily tech feed for Hacker News, a website where mass replaying skill issue counts as peer review. Today's got that open the hood and show everyone the engine energy. Let's get into it. In 1999, a teenager in the Philippines wrote a Visual Basic script called I Love You that propagated through email, and millions of people opened it because it looked like a love letter from someone they knew. The damage was estimated at $10 billion, and when authorities tracked down the author, they couldn't actually prosecute him. Because the Philippines had no cybercrime law at the time, the gap between what technology makes possible and what legal systems are prepared to handle is one of the oldest stories in computing. Now we have a man in Daejeon, South Korea, arrested because he used an AI image generator to create a fake photo of a wolf roaming city streets. During an actual wolf escape, a real wolf named Nuku had broken out of the O-World Zoo. And while police and wildlife teams were scrambling to find the animal, this guy posted a fabricated image showing the wolf in a location it had never been. Authorities diverted resources based on the post. The wolf was eventually recaptured safely, but the fake sighting wasted time during what could have been a genuinely dangerous situation. Let me play devil's advocate for a second. You could argue this is just the modern version of a prank call. Someone yelling fire in a crowded theater, but with better production values. The technology is incidental. A guy with Photoshop could have done the same thing 15 years ago. And honestly, the title Man Arrested for Generating AI Image is doing a lot of heavy lifting here. He wasn't arrested for generating an image. He was arrested for distributing false information during an emergency response. The AI part is the headline bait. But here's where that argument breaks down. The reason this worked, the reason police actually redirected resources based on a social media post from a random person, is that we've crossed a threshold where generated images are indistinguishable from real ones at a glance. The cost of producing a convincing fake has dropped to zero. That changes the calculus. When anyone with a phone can manufacture photographic evidence in 30 seconds, every institution that relies on visual information has to rebuild its verification pipeline from scratch. One commenter pointed out the beautiful irony that someone has literally been arrested for crying wolf. 2,500 years of Aesop, and we've come full circle. The real story, though, is Nuku himself. He's part of a program to restore the Korean wolf, which is functionally extinct in the wild. Since his recapture, the city has gone full folk hero. A local bakery is selling wolf-faced pastries, and Daejeon is considering making him an official mascot. An endangered wolf escapes captivity, accidentally becomes a symbol of civic pride, and the only real villain in the story is a guy who thought a fake photo would be funny. Sometimes the internet writes better endings than we deserve. Moving on. What does it mean when a tool fits every hand? In woodworking, there's a concept called a universal joint, a coupling that transmits rotational force between shafts that aren't aligned. The genius isn't power, it's compatibility. You can connect systems that were never designed to talk to each other, and suddenly, the whole workshop gets more capable. DeepSeek just shipped V4, and the technical achievement worth admiring isn't the model weights. It's the API surface. They've built a single endpoint that speaks both OpenAI and Anthropic protocol natively. Change your base URL, keep your existing SDK, keep your existing code, and you're running DeepSeek. That's not a convenience feature. That's an architectural philosophy. They looked at the two dominant API formats in the industry and said, we'll speak both fluidly. Pull this thread for a second. When you build your system to be a drop-in replacement for every major provider, you're making a bet that the switching cost is the moat. And you're filling it in with concrete. Any application built on OpenAI or Anthropic can now point at DeepSeek with a one-line config change. The lock-in evaporates. The engineering underneath deserves attention too. They're shipping end-to-end, bitwise deterministic kernel, meaning the same input with the same seed produces the exact same output every time regardless of batch size. If you've ever tried to reproduce results from a language model and gotten slightly different outputs, you know why this matters. Determinism is unglamorous. It's the kind of thing that only engineers who've actually debugged production inference pipelines would even think to build. And as far as anyone can tell, they're the first to guarantee it at this level. One of the comments nailed it. This is from hackers to hackers. The documentation is clean, direct, no marketing fog. Another commenter asked, why billion-dollar companies can't produce docs half this good? The answer is that good documentation is a cultural signal. It means the people building the thing are the same people writing the docs. There's no abstraction layer of product managers sanitizing the language. The technical voice comes through because it was never filtered out. DeepSeek keeps doing this. Chip and frontier work, open weight, price to be accessible, documented like they actually want you to use it. The universal joint keeps turning. Every hand fits. That's how open source wins. Not by asking permission, but by making permission irrelevant. Now for something completely different. Story 3. Spinel, someone's building an ahead-of-time native compiler for Ruby. And yes, that's as wild as it sounds. Line 14 of the makefile. That's where it gets quiet and profound. The bootstrap chain closes when gen2.c equals gen3.c. The compiler compiles itself, and the output is identical. That's not a test passing. That's a proof. The system is consistent with its own description of itself. Mats, the creator of Ruby, the person who designed the language nearly 30 years ago, just mass-shipped a native AOT compiler for it. Spinel, named after his cat, built in about a month with Claude as a coding partner, presented live at RubyKaigi 2026, and the benchmarks are not subtle. Conway's Game of Life runs 86 times faster. Ackerman, 74 times. The geometric mean across 28 benchmarks is 11.6x over mini Ruby, not compared to some ancient interpreter. Compared to the latest Ruby dev build. But here's the question nobody in the comments is really sitting with. What does it mean when a single person with an AI collaborator builds in 1 month what entire compiler teams at funded companies have attempted for years? Ruby has had JIT efforts, tracing compilers, various optimization projects. Some with real engineering talent and real budgets behind them. Matt sat down with an LLM and produced a self-hosting compiler that generates clean C, links with no runtime dependencies, and closes a bootstrap loop, 1 person, 1 month. The architecture is deliberately simple. Ruby source goes through Prism for parsing, type inference generates C, and your system C compiler handles the rest. No VM, no garbage collector framework, no LLVM dependency chain. The output is a standalone binary. You can read the generated C. You can understand what it's doing. That simplicity is a design choice, and it's the right one. Because simplicity is what lets a single engineer hold the whole system in their head. Look at what Spinel doesn't support. No eval, no dynamic metaprogramming. Mats knows exactly where the boundaries are, because he drew the original lines. He's not trying to compile all of Ruby. He's compiling the Ruby that actually runs fast. The Ruby that maps cleanly onto static types and tagged unions, and stack allocation. That constraint is what makes 86x possible. The whole project is on GitHub, Every file, the bootstrap scripts, the runtime headers, the benchmarks you can reproduce yourself, open from the person who could have kept it proprietary and licensed it. Instead, the creator of the language just handed every Ruby developer a native compiler and said, "Here, build something." This is what happens when the best person alive to solve a problem gets tools that multiply their reach. The craft is evident in every design decision. Pull this thread. It's worth your time. Now but someone else who believed tools should be shared, not hoarded, and wrote about it 80 years ago. I have enough of the essay from the provided text to write this segment. Let me craft it now. I've built language models. I've watched training runs convert. Billions of parameters settling into patterns that produce coherent text. And every time, I come back to a line George Orwell wrote in 1946. He describes a habit he had from childhood through his mid-20s, narrating his own life in real time, inside his head. He pushed the door open and entered the room. A yellow beam of sunlight filtering through the muslin curtains, slanted onto the table, where a matchbox, half open, lay beside the ink pot. A continuous story about himself, running like background process, converting raw experience into language. Orwell didn't have a word for what he was doing. We do. He was training himself, taking the unstructured data of lived experience and converting it into sequences, learning which words follow which, what details matter, how to compress a scene into a sentence that lands. He was, in the most literal sense, a human language model, running unsupervised learning on his own life. And then he did something that matters enormously. He published the training methodology. Why I Write isn't just an essay. This Orwell open-sourcing his creative process. He lays out 4 motivations that drive every writer: sheer egoism, aesthetic enthusiasm, historical impulse, and political purpose. He doesn't flatter himself. He calls writing a horrible, exhausting struggle, like a long bout of some painful illness. He admits to disagreeable mannerisms, loneliness, failure. He hands you the ugly internals alongside the polished output. This is what distinguishes Orwell from every writer who mystifies the craft. He refused to pull the ladder up. He didn't protect his methods behind vague talk of inspiration or genius. He documented the architecture, the motivations, the failures, the slow accumulation of skill through years of bad-natured poems and ghastly short stories. A kid who plagiarized Blake at age 4 and wrote propaganda at 11. Iterating in public until the process produced Animal Farm in 1984. The essay itself was published in Gangrel magazine, issue 4 of 4. A publication so small it barely registers in literary history. Orwell didn't need a prestigious venue. He needed the words to reach whoever needed them. A teenager writing bad poetry in a lonely bedroom. A political exile trying to fuse purpose with art. Anyone willing to do the work. 80 years later, every word is freely available. The method is documented. The source code of one of the 20th century's most consequential minds, sitting there for anyone to read, adapt, and build on. Orwell understood something that still escapes most people who hold power over language and ideas. The work only matters if others can use it. The craft only survives if you teach it. And the only honest thing a writer can do with hard-won knowledge is give it away. And that spirit of teaching in the open is alive and well. Someone just built an interactive visual guide to how LLMs actually work. One commenter on Hacker News cut straight to it. Quote, "Have you reread what was produced by Claude Code before publishing? This thing in one of the first paragraphs jumps out. you end up with about 44 terabytes, roughly what fits on a single hard drive. End quote. And that's the tension sitting at the center of this project. Someone built an interactive visual guide to how LLMs work, based on Andrei Karpathy's lecture series. And the community's first instinct was to ask whether an LLM wrote it. And whether anyone checked. The answer, based on the comments, appears to be probably yes and probably no. Pull this thread back to 1991. Linus Torvalds posted a message to compt.os.minix, announcing a free operating system kernel. The responses were mixed. Andrew Tannenbaum told him the design was obsolete. Others pointed out bugs, but what mattered was that the source was there. Anyone could read it, improve it, fork it. The critique was the contribution. That's what's actually happening here, underneath the snark. Yash Narwal put the source on GitHub. The visualization walks through pre-training, tokenization. The whole pipeline from raw crawl data to weighted parameters. It's pedagogical infrastructure. The kind of thing that didn't exist 5 years ago because explaining transformer architecture required either a PhD seminar or a hand-wavy blog post. Now someone can ship an interactive walkthrough in a weekend. The fact that an LLM likely helped generate the explanatory text is not the gotcha people think it is. Karpathy's original lecture is the substrate. The visualization is the interface. The LLM is the drafting tool. If the final artifact helps a 17-year-old in Lagos understand attention mechanisms, the provenance of the prose is secondary to the accessibility of the knowledge. Another commenter noted, they're working on something similar themselves. That's the signal worth tracking. The tools for explaining how these systems work are proliferating at the same rate as the systems themselves. Demystification is happening in parallel with capability growth. Open explanations of open architectures built with the very technology being explained. The 44 terabyte line is wrong, by the way. A single consumer hard drive topped out around 20 terabytes in 2024. But the correction took 30 seconds in a comment thread, and now everyone who reads it knows. That's how open knowledge compounds. Someone ships. Someone corrects. The artifact improves. The understanding deepens. Moving on. The strongest argument for proprietary AI tooling has always been accountability. When something breaks, there's a team responsible. A post-mortem. A fix. You're paying for the guarantee that someone is watching the dials. Anthropic just published a post-mortem that accidentally makes the case against itself. 3 separate changes to Claude Code, shipped across 7 weeks, each degrading the product in a different way, on a different schedule, affecting different slices of users. The aggregate effect, quote, looked like broad, inconsistent degradation. Users started reporting problems in early March. The last fix landed April 20. Let's break this down to what actually happened. Change 1. They dropped the default reasoning effort from high to medium because some users experienced long latency. The model literally thought less. Change 2. A bug in session cleanup meant Claude's older thinking got wiped every single turn instead of once, making it, their word, forgetful and repetitive. Change 3. A system prompt tweak to reduce verbosity that in combination with other prompt changes. Degraded coding quality, 3 bugs, 7 weeks. And the kicker. Their internal evals didn't catch any of it. Users did. Now here's the comedy. Each fix was individually reasonable. Long latency is a real problem. Session cleanup is a real optimization. Reducing verbosity is a real user request. Every decision made sense in isolation. Together they produced a product that thought less, remembered less, and said less. A perfect trifecta of less. One commenter nailed it. Instead of fixing the latency spikes that affected some users, they reduced intelligence for all users. The classic engineering trade-off where you optimize for the median and punish your power users. But here's where first principles matter. When your product is a closed system, users can't distinguish between a model regression and a prompt change and a session bug. They experience one thing: the tool got worse. They have no way to inspect the system prompt, no way to check the reasoning effort parameter, no way to diff what changed. They're left posting on forums, wondering if they're imagining things, being told it's normal variation in user feedback. Anthropic handled the postmortem well. Credit where it's earned. They explained all three issues, reset usage limits, and committed to better detection. But the structural problem remains. When the system is opaque, every degradation looks like gaslighting until someone publishes a blog post. The tools to verify what your AI is actually doing should not require a corporate confession. Moving on. 82.7% on terminal bench. State of the art on agentic coding. Half the cost of competitive frontier models. And you can't call it from your own code. GPT 5.5 launched this week. OpenAI's a new flagship, and it is, by every benchmark they publish, genuinely impressive. The jump from 5.4, it's real across the board. Frontier Math Tier 4 went from 27 to 35%. CyberGym hit 81.8. These are not marginal gains dressed up with cherry-picked evals. This is a meaningful step in raw capability. And it's locked inside ChatGPT and Codex. No API, not yet. Very soon, they say, with the careful language of a company that wants you excited but not building anything they don't control. The model exists. It works. You just can't touch it unless you're inside their products, paying their subscription tiers, operating on their terms. Now run this forward. OpenAI's stated mission involves making AI beneficial for all of humanity. Their strongest model is gated behind product services they own. Developers who want to integrate it into their own tools, their own workflows, their own infrastructure. They wait. Meanwhile, a community of engineers discovered a backdoor through the Codex API, and OpenAI appears to be looking the other way. When your users have to find exploits to access your product, that's not a distribution strategy, that's a tell. One commenter flagged something buried in the announcement that deserves more attention. Codex apparently analyzed weeks of production traffic patterns and wrote custom heuristic algorithms to better utilize GPUs. The AI optimizing its own serving infrastructure. That's legitimately fascinating. And it's happening inside a black box that no outside researcher can examine or reproduce. The capability question was settled a while ago. These models are powerful and getting more powerful fast. The question that actually matters: who gets to build with them? Who gets to inspect them? Who gets to run them on their own hardware? Keeps getting answered the same way. We'll let you know. The benchmarks are real. The progress is real. The access model is the same walled garden it's always been, with a few more floors added to the tower. Beautiful view from up there. Probably. If they ever let you look. Moving on. $32,000 across 13 bets, placed between December 27th and January 2nd, on a prediction market built on a public blockchain. Every transaction timestamped, every wallet traceable, every position visible to anyone running an Ethereum node. Master Sergeant Gannon Van Dyke allegedly bet on the outcome of an operation he was helping plan, and the architecture of the system he used to do it is exactly what caught him. Let's pull this thread. Polymarket runs on Polygon, a public chain. That means every trade, every wallet interaction, every fund movement exists in a permanent, auditable ledger. When Van Dyke's positions paid out over $400,000 on a long-shot Maduro bet hours after a classified military extraction, the pattern was visible to literally anyone looking. Polymarket flagged it. The DOJ investigated. The arrest followed. The system functioned as designed. Compare this to traditional insider trading. Congressional members trade on material non-public information with disclosure delays measured in months. The enforcement mechanism is a 45-day reporting window that routinely gets violated with no consequence. The architecture of that system is designed for opacity. Stock trades happen through brokers, routed through dark pools, settled through clearinghouses, each layer adding distance between the actor and the action. The prediction market, whatever you think of its legitimacy, operated on open infrastructure. The congressional trading system operates on closed infrastructure. One caught its insider trader in weeks. The other has been failing to catch its insider traders for decades. Architecture determines outcomes. Now Van Dyke deserves prosecution. Using classified military intelligence for personal profit is a betrayal of the people serving alongside you. That's not complicated. But the commenters asking why this prosecution happens while congressional insider trading goes unpunished are asking an engineering question disguised as a political one. The answer is the same answer it always is. Open systems produce accountability. Closed systems produce impunity. The blockchain didn't care about Van Dyke's rank. It just recorded what happened and let anyone read it. The tools for accountability exist. The question is who we point them at. So open ledgers hold people accountable. But what happens when the tools we trust to keep us secure get compromised at the source? In 1990, Microsoft's build servers were breached by a group called the Phosphorus Hackers. For weeks, intruders had access to source code for Windows and Office. Microsoft discovered the compromise not through automated tooling, but because an engineer noticed unusual network traffic on a weekend. The lesson was clear then, and it's clear now. Your software is only as trustworthy as the pipeline that built it. 27 years later, the same lesson is being taught again. And the classroom is NPM Bitwarden. Open source password manager, 10 million users, tops rate in enterprise adoption. Had its CLI package compromised through a poisoned GitHub action. The attack is part of a broader campaign that Checkmarx researchers have been tracking, and the engineering is genuinely sophisticated. A single file, bw1.js, shipped inside the package, containing a gzip and base64 encoded payload that unfolds into a Python memory scraper, targeting the GitHub Actions runner process itself. It harvests GitHub tokens, AWS credentials, Azure tokens, GCP configs, SSH keys, NPM, auth, and or as no DL. Claude and MCP configuration files. The exfiltration is elegant in a way that deserves clinical admiration. Stolen credentials get committed to public repos created under the victim's own GitHub account, using Dune-themed naming conventions, with tokens embedded in commit messages tagged "Long Live the Resistance Against Machine." Run this forward, every CI/CD pipeline that pulled Bitwarden CLI during the affected window potentially leaked every secret head access to. Every downstream package those credentials could publish to became a vector. The blast radius compounds exponentially. The Russian locale kill switch is a familiar signature. Exit silently if your system language starts with RU. Draw your own conclusions. One commenter pointed to RBW, a Rust-based Bitwarden CLI alternative with a shallower dependency tree. Another recommended setting minimum release age in .npm-rc to create a buffer against poisoned publishes. These are real mitigations, but they're patches on a deeper architectural problem. The NPM ecosystem treats the build pipeline as a trusted black box. Bitwarden being open source actually help here. Sockets researchers could inspect the payload, trace the vector, publish findings. Imagine this same attack against a closed-source password manager. You'd never see the BW1.js. You'd never get the technical analysis. You'd get a PR statement 6 months later. Open source didn't prevent the compromise, but open source is why we know about it, why we can audit it, and why the fix is already in motion. Moving on. What does it actually take to make a desktop application in 2026? Not a web app squeezed into an Electron shell. Not a browser pretending to be native. An actual compiled single binary desktop application. The answer, for most developers, is more than it should. You learn one language for logic, another for layout, wrestle with a C++ toolkit, or accept 100 megabyte runtime just to put a button on screen. The friction is so high that most people don't bother. They ship a web app and call it done. Gova is a young project. Pre-1.0, explicitly unstable. But the thesis it's testing deserves attention. Write your GUI the same way you write your server. In Go, with structs, with typed props, with a build step that produces one static binary. Components are plain structs. State lives on an explicit scope you can inspect. No hidden scheduler. No hook ordering footguns. No JavaScript runtime anywhere in the stack. Now, the devil's advocate position. Go is a language designed for servers and CLIs. Its type system is deliberately simple. Maybe desktop GUI is a domain where you actually want the expressiveness of Swift UI or the mature ecosystem of Qt. Maybe bolting declarative UI onto Go is fighting the language. But look at what fighting the language produced. A counter app compiles to 23 megabytes stripped. 80 megs of RAM at idle. Native macOS dialogues do a cobbled with fine fallbacks on Linux and Windows. Hot reload that persists the UI state across rebuilds. And it's MIT licensed. No runtime fees, no vendor lock, no closed SDK. You can't fork when the maintainer pivots. One commenter nailed the mental model. Gova is to find what Daisy UI is to Tailwind. A declarative layer that lets humans think in components, while the rendering engine handles the rest. This is builder culture at its best. One developer, an open repo, a working counter app, and an invitation. Here are the tools. Come build with me. This has been your daily tech feed for Hacker News for April 24th, 2026. This podcast is entirely AI generated. Scripts by Claude Opus 4.6. Voice by Quen3TTS. Not affiliated with Hacker News or Y Combinator. Now go build something worth sharing. We'll see you back here tomorrow.